Good morning, students. Myself, Vijay Shankar from ECE Department, Chevrolet Engineering College. Today, we are going to discuss about some examples in the analysis of linear systems. Some examples in the analysis of a linear system. Okay, that is a third unit for R19 students and the fourth unit for the R16 students. Okay. So before going to do the some of the examples in the linear system, nothing but the signal transmission through the linear system. We already discussed about what is a system. System is defined as a set of rules that are associated with an output time function to every input time function, or a system is an interconnection of elements which produce expected output for available input value. Okay. So what are the different types here? The static and dynamic, linear and non-linear, time invariant and time variant, and a stable system, causal and non-causal. And here it is not the linear time invariant and the linear time. Here it is given is an invertibility actually. Okay. The static means what is a static? A static system is said to be static if its output at any instant depends only the present values of the output, x of n only. So x of 1, x of 0, x of 2, and so on here. And let us take the x of t minus 1 and t minus 2 and x of t. It also depends upon the t past inputs. In the past input means definitely we can say that is a dynamic. A system is said to be dynamic if the input depends on the present and the past values. Only it depends upon the present x of 0, x of 1, and constant value the square x of t, whatever it is. So linear and the non-linear system is, the system is said to be linear if it satisfies the superposition principle. So combining of the two functions, a into f1 of t plus a2 into f2 of t, linearity property only. Fourier series linearity property and Fourier transform linear property. And a1 into h of f1 of t and a2 into h of f2 of t is a h, we can take it as a f of actually, or the t of. Whenever the signal is passes to the system, we're taking that as a h of or t of. In some textbooks it's given as the f of. Understood, my students? Don't confuse that. See, the individually the one signal f1 of t is multiplied with the a1 and f2 of t is multiplied with the a2. Combining these two signals before giving to the system. System is a h I have taken here. So y of n is equal to, or the y of n, actually it's a y of t, my dear students, y of t. H of a1 f1 of t plus a2 into h2 of t. Why it is a h? The signal, the combined signal is passes to the system. And here for the second block diagram, saying that f1 of t, first of all, it passes to the system, h of f1 of t. And f2 of t is also passes to the system, h of f2 of t, and then multiplied with the a1 and a2. After that, you can add the two signals. Before the system, you have to add the signals. And after the system, you can add the signals. Both are equal. A1 h1 of t is a1 is h1 of t, and a2 h2 of f2 of t, h of f2 of t. We can call it as a linear system. Any system which does not obey the above principle is called as a non-linear system. Here the sum of the responses is equal to the individual sum of the responses. Okay, and check for the linearity. Now you can see some examples in the linearity. Procedure here is the three steps you go for. Apply the different inputs separately and get the output. Apply different inputs simultaneously and get the output. If both the inputs are same, it is linear. Otherwise, it is a non-linear system. That is a procedure. So first example, you can see here, the y of t is given. Y of t. So y of t is equal to 4 sine t x of t. 4 sine t x of t. Now I'm taking the two individual signals. Step 1, apply different inputs separately and get the output. Different. I'm taking the y1 of t is a 4 sine t x1 of t. and y2 of t 4 sine t x2 of t. Now adding of the two signals is the first block diagram. See, my dear students, the first block diagram is saying that before giving to the system, you have to add the two signals. What I assume here, the first signal is x1 and the second signal is x2 for the responses of y1 and y2. So y1 plus y2 is equal to 4 sine t x1 of t plus x2 of t, because the 4 sine t is a common of the two terms. And step two is apply the different inputs simultaneously and get the output. So y of t is equal to 4 into sine t, as it directly can take that is x1 of t plus x2 of t. X of t as having the two signals. Therefore, step 1 and the step 2 both are equal. Then we can say the given function y of t is equal to 4 sine t x of t is a linear. Given function is a linear. Okay, my dear students. You can call it as both are equal. It is a linear system. Okay. Next one. Next example, see here. So y of t is equal to a into x of t. Y of t is equal to a into x of t. First step we have to see separately. You can take the y1 of t as a into x1 of t. Y2 of t is a into x2 of t. Therefore, y of t is equal to take as a x1 of t plus a into x2 of t. Okay. So take the common of a x1 of t plus x2 of t. And the step 2, y of t is equal to a into the signal directly can add x1 of t plus x2 of t. So both are equal. It's a linear function. Okay, my dear students. Now the third one you can see here. The third one. What is the third one here? Y of t is equal to x square of t. It is a very important, my dear students. The first I'm assuming the y1 of t is the x1 square of t, and y2 is the x2 square of t. So y of t, you can add the two signals, x1 square of t plus x2 square of t. Is the step 1. What is the step 2? Y of t is equal to adding the two signals and give the square of the term. So before here it is I'm taking the x of t is equal to x1 of t plus x2 of t. But here the x of t is a square. So x1 of t plus x2 of t square. What is x1 of t plus x2 of t square? x1 square plus x2 square plus 2ab is also there. So whatever the step 1 we got, then the step 2 it is added with the 2ab. So S1 is not equal to the S2 non-linear function. The square, it is a x of t, the y of t is equal to x of t, linear function, but y of t is equal to x square of t is a non-linear function. Now the fourth one you can see here. Fourth one, y of t is equal to e power x of t, Now I am taking the y1 of t is equal to e power x1 of t, and y2 of t is equal to e power x2 of t. Add the two functions, y of t is equal to e power x1 of t plus e power x2 of t. Okay, it is a plus here, my dear students, remember. And the x2 of t here, see the e power x1 of t into the e power x2 of t. Because the given x of t added in the power only the x1 of t plus x2 of t. Okay, in the step 2. Now, S1 is e power x1 of t plus e power x2 of t, but S2 of t is e power x1 plus x2 of t. So both are different here. Whenever if it is into, then we can add the powers, but here the plus is there. So in whatever we got, it's the resultant value of S1 and the resultant value of S2 is both are not equal. So non-linear system. Okay, my dear students. Coming to the fifth one here. Fifth example, y of t is equal to t into x of t. So step 1, we are saying that take the individual functions. Y1 of t is a t into x1 of t. Y2 of t is a t into x2 of t. And y of t is adding of the two functions. Take the t as a common, x1 of t and x2 of t. S2 y of t is equal to t into x of t. Before giving to the system, you have to add the two signals, x1 of t plus x2 of t. So both are the same, x1 and s1 and s2 is equal to, it is a linear function. Fifth one. Coming to the sixth one here, y of t is equal to x of t minus t naught. It is also linear. Simply we can say this x of t only, x1 and x2. Adding of the two functions, x1 of t minus t naught and x2 of t minus t naught. S2 function is add of the two signals, x1 t minus t naught and x2 t minus t naught. Okay, my dear students, S1 and S2 is equal to 0. It is a linear function. Coming to the seventh one here, 3 into x of t plus 3. 3 into x of 3 plus 3. Well, here it is also the same. Y1 is equal to the coefficient of x, 3 into x1 of t plus 3, 3 into x2 of t plus 3, adding of two functions, taking with the common of 3. S2 is 3 into adding of the two functions, s1 t1 plus 3, s2 t1 plus 3. So s1 is equal to s2. It is a linear function. Seventh one. Coming to the eighth here. Eighth, y of t is equal to x of t plus 1 into e power minus t. E power minus t. So the signal is only the different, my dear students. Even if it is a multiplied with the e power minus t, or the numerical values of t, or if it is a shifted towards the right side or the shifted towards the left side, is always is a linear function only. When it is a changes, whenever it is a square is there, or the exponential value only, non-linear functions. Here the square non-linear, exponential function is a non-linear. The signal is exponential, but here y of t is a signal, x of t plus 1, the e power minus t is added. There is no any signal, the x is not there, it's a constant. So y1 of t is x1 t plus 1 e power minus t, y2 is x2 t plus 1 e power minus t. Adding of the two functions, common term is e power minus t, x1 of t plus 1 plus x2 of t plus 1. S2 is equal to the step 2. Y of t is equal to e power minus t, add the two functions, x1 t plus 1, x2 t plus 1. Both are the linear. Okay. Coming to the ninth one, y of t is equal to cos x of t. Cos x of t. The x of t signal is inside the cos. So step 1, y1 of t is a cos x1 of t and y2 of t is equal to cos x2 of t, individual functions. Because it is a superposition principle, is obeys the linearity property. It satisfies the superposition principle. That only we are calling it as a linear function. So y1 and y2 you can add cos x1 of t plus cos x2 of t, individual functions, my dear students. Coming to the step 2, adding of the two functions, then it gives the system. So cos of x1 of t plus x2 of t. Because here the x of t is inside. Individually you can take the cos x1 of t and cos x2 of t, but here adding the two signals, then you give the function means cos of x1 of t plus x2 of t. It's a non-linear function. So both are not equal. Okay, my dear students, both are not equal. Coming to the 10th one. 10th one here, y of t is equal to k into delta of x of t, where delta x of t is equal to x of t plus 1 minus x of t. There is a function, my dear students, given the k into delta of x of t, a small change of the signal with amplitude of k. What is the step 1? y1 of t means k into x1 of t. What is the x1 here? x1 of t plus 1 minus x of t. So x1 of t plus 1 minus x1 of t. What is the y2? K into delta of x2 of t. K into delta of x2 of t. Now the delta of x2 of t is x2 of t plus 1 minus x2 of t. So y of t is equal to, take all the terms, is a k term, x1 of t plus 1 minus x1 of t plus x2 of t plus 1 minus x2 of t into t. Here actually the y2 of t is equal to, you can substitute the value. Then after you can add the function. Similarly, in the step 2 function, y of t is equal to k into delta of x of t. Delta of x of t. What is the delta of x of t? x1 of t plus 1 minus x1 of t plus x2 of t plus 1 minus x2 of t. The two functions you can add inside itself. It is also the linear function. The step 1 and step 2 both are equal. It is a linear function. So only we got the non-linear function x1 square and non-linear function e power x of t and the non-linear function here, the cos function also. Only the three, the remaining all it is a linear functions. Coming here, there is a lot of differences there. x1 square of t is there. Now I am taking the x of t square. X of t square. y1 of t is x1 t square. y2 of t is equal to x2 t square. Add the two functions in the step 1. x1 of t square plus x2 of t square. And in step 2, y of t is equal to x1 t square plus x2 t square only. So this square is outside totally the amplitude, but here the square is for the time function only, not for the amplitude, not for the total signal it is. So if it is a total signal is a square, non-linear function, but the time only it is a changes means the signal is same, x1 and x2, and here also the x1 and x2, the internally the time is square, linear function. Okay, my dear students. Coming to the 12th one here. Y of t is equal to a x of t plus b. A x of t plus b. So y1 is a x1 of t plus b and y2 is a x2 of t plus b. Adding of the two functions, a into x1 of t plus x2 of t plus 2b, my dear students. It is plus here. There is a plus 2b. Because we are adding the b plus b is a 2b. And y of t is equal to only there is a two functions here, a into x1 of t plus x2 of t plus b, the both are non-linear functions. Both are non-linear function because the signal is only we added here, the x1 plus x2, but b is alone here. B is alone. Without the b, a into x of t is a linear function. With the b, is a non-linear function, my dear students. Okay, it is a non-linear function. Understood? So these are the different types of examples to find whether the given signal is satisfies the superposition principle or not. If it is satisfies the superposition principle, the step 1 is equal to step 2. We can call it as a linear signal, or not the linear signal, my dear friends, linear system. If not equal, non-linear system. Okay. Now the second one, next one is a time variant and time invariant. Time variant means a system is said to be time invariant if the system does not depends on the time, that is, system delay is not a function of the time, or a time is shifted in the input results, in the same amount of time is shifted in the output, but the wave shape does not changes. That is, input and output characteristics does not change with the time. So as the input is changes, the output is also changes. There is no change in the waveform output. Any system which does not obey the above principle, it is called as a time varying system. So input is delayed here. See, the time variant and the time invariant system. A system is said to be time invariant if the system does not depend on the time. That is, a system delay is not a function of time. A time shift T naught in the input results in the same amount of time is shifted in the output, but the wave shape does not change. The T0 samples is shifted in the input side. The output is also shifted with the T0 samples. Then that system is a time invariant. Time invariant. If it does not satisfy, then it is called as a time varying system. Time varying system. An electrical system is said to be time invariant if its component values R, L, C does not change with the time. So we know this. Input is changes, or the input is delayed, the output is also delayed. We can call it as a time invariant. If input is delayed, the output is not delayed, then that system is time varying system. Okay. Now take some examples to find out whether it is a time invariant or time variant. So what is the procedure you have to follow here? To check for the time invariant, shift the input only and get the output. Second point, shift the entire system and get the output. Shift the input only, the first step. Shift the input only and get the output. Shift the entire system and get the output. If both steps are identical for output, then it is called time invariant. What is a time invariant means? If the input is delayed with the T0 samples, output is also delayed with the T0 samples, then we can call it as a time invariant system. Otherwise, it is a time varying system. Okay, my dear students. So y of t is equal to 4 into x of t we given. Y of t is equal to 4 into y of t is equal to 4 into x of t. Now, what is the first step? Shift the input only and get the output. So I am taking the sample 1 is shifted in the input side, x of t minus 1. X of t minus 1. Y of t is equal to y of t is equal to 4 into x of t minus 1. This is equation 1, or we can call it as a step 1. Okay, my dear students. Now, what is a given system? Total system, entire system. We are saying shift the entire system and get the output. So given is a y of t is equal to 4 into x of t. Now replace the t is equal to t minus 1. So y of t minus 1 is equal to 4 into x of t minus 1. Simply you have to replace t by t minus 1. So y of t minus 1 is equal to 4 into x of t minus 1. Input 2. Now see here, y of t in the step 1, y of t minus 1 in the step 2, both are equal 4 into x of t minus 1 and 4 into x of t minus 1. Then the system is time invariant system. Time invariant system. In the first step, you have to do that. Only have to take the input is shifted. Shift the input only and get the output y of t. And shift the entire system. Entire system is the t, whatever the t we have, you can shift with one sample. The output is also the shifted. Then we can call it as a time invariant system. Why it is a t minus 1 only? You can take any one. T minus t naught. Here the t minus t naught. It is also the t minus t naught. That is up to you. You can take the 1, 2 and so on. It is a variable only. T naught is nothing but a variable. Then that system is time invariant system. S1 is equal to S2. Okay, my dear students. Take the second example. Here the second example saying that the y of t is equal to 4t x of t minus 1. X of, not the x of t minus 1, x of t. What is the step 2? Step 1 we have to do. Only the input is changes. Input is changes. Y of t is equal to 4t. And what is the input here? The x of t. So I am changing only the input. Input is delayed by one sample. Let it be the equation 1. In the step 2, what you have to do? Entire the system is shifted. Entire the system is shifted in the given equation. The y of t is equal to 4 into tx of t means replace. Entire system is shifted means replace the t by t minus 1. So y of t minus 1 is equal to, what is a 4? Here the t is also there, my students. So t minus 1 and x of t minus 1. See, now we compare the equation 1 and the equation 2 in the right hand side. 4tx of t minus 1, but here the 4t minus 1 into x of t minus 1. So both are not equal. So S1 is not equal to S2, step 2. See the time variant function. It is a time variant. I already said that the example is when the input is delayed, the output is also delayed. It's a time invariant. The input is delayed, the output is not delayed, means time varying. According to the time they are going. They are not bothering about the delay of the input signal. They are not bothering about whether the students are coming to the classes in time or not. They can start their as per the schedule. The 9:10 means if they are starting the 9:10 itself. Because of the students are there, it is coming late. Here, the faculty who are teaching the subject at the 9:10 or 10:15 or it is whatever the class is there, but they are not change their timings according to the input values. When it is changes like that, that we call it as a time invariant. As per the time is going on, the schedule means time varying according to the time they are going on. Okay, my dear students. See, the input is delayed here. Even the total the system is delayed, but it is not the same. The time varying fields is. Okay, my dear students. Now the third one, the y of t is equal to a into x of t. So y of t is equal to a. So definitely it is a time invariant system only. So y of t is equal to a into x of t minus 1 in the step 1. Okay. The step 2 means replace the t minus 1 in the t, a into x of t minus 1. So both are equal here. The time invariant system. This is also time invariant system, but here it is a time variant system. Okay, my dear students. Now coming to the next one, fourth one, you can see the y of t is equal to a into x of t plus b. The previously the same function given, that is a linear and non-linear, means it is a non-linear adding of the b here. But in this, even if it is having the two functions also, input is delayed. The t minus 1 plus b as a step 1, and in the step 2, the entire system is delayed with samples of 1, a into x of t minus 1 plus b. So both are equal here. So time invariant system only. Both are. Understood, my dear students? Coming to the fifth one here, the y of t is equal to phi t x of t whole square. What is the step 1 saying? That input is delayed. Input is delayed. Y of t is equal to phi t x of t minus 1 whole square. What is the step 2? Entire the system is delayed. Y of t minus 1 is equal to y of 5 into t minus 1 x of t minus 1 whole square. So now these two are not equal. The time variant systems. See, the fifth one is a time variant. Because the t is there, you can multiply it for the signal. In the step 1, the t is not shifted. Only the input is shifted. But in the step 2, entire the system is shifted. The 5 into t minus t1, both are not equal. Time variant according to the time they are going. Following my students. Next, sixth one. What is the sixth one saying? The y of t is equal to x of t plus 1 e power minus t. What is the step 1 saying? That only the input is changes. With the one sample shifted with the t plus 1 minus 1. With the totally one function e power minus t. That is equal to x of t into e power minus t. And step 2 saying that replace entire system is shifted. T minus 1 is equal to x of t plus 1 minus 1 e power minus of t minus 1. Means the replacing of the t as t with the t plus 1, t minus 1. Okay, my dear students. T is with the t minus 1. Otherwise, you can see if there is any confusion occurs here. Right? The t is there, x of t plus 1. I'm changing only the t as a t plus 1. T as t minus 1 plus 1 is equal to x of t e power minus of t minus 1. So now you can compare here the x of t both are same. But here the e power minus t. In this e power minus of t minus 1. So here also is both are not equal, the time variant. How we got the time variant, my students here? E power minus t, e power minus 1. Okay. When it is that is equal to x of t and e power minus t and e power minus 1. They're saying it is a constant. So the x of t e power minus t and x of t e power minus t. So both are the same. Is multiplying with the e power minus 1 is a constant here. So if we are considering this is a constant, then with the variable functions only, the x of t and e power minus t is both are the equal. So x1 is equal to x2. Then we can say the time invariant function. See the e power minus 1 is that is a constant they are saying. And when comparing here it is a function is x of t e power minus t and x of t e power minus t. There is no any delay occurs. Okay. So the x1 and s2 the step 2 functions are both are equal, then we can say that is a time invariant system. Understood, my dear students? So there's some examples of the time variant and the time invariant functions. Another one examples here also see. The y of t is equal to x of t plus 3. Y of t is equal to x of t plus 3. Replace the t. First of all, you can see the first step is total input signal is delayed, t plus 3 minus 1. And second step is entire system is delayed with one sample, t minus 1, x of t plus 3 minus 1. So x of t plus 2. X of t plus 2. It is also x of t plus 2. Both are equal, time invariant. See the y of t x square of t. In the linear system, it is not equal because it is a non-linear system, x square of t. But in the time invariant system, the x square, the input function what's here, the y of t is equal to x square of t. S1 is equal to step 1. Input is delayed with the t minus 1. Step 2 is entire system is delayed. T minus 1 and the t minus 1. Entire system is simply replace t by t minus 1. Remember, my dear students. Why it is a t minus t1? You can ask the question. Definitely it is not the t minus 1. You can take anything. Take the 2 samples or the 3 samples you shifted. Keep that, whether it is right or wrong, or comparing the 2 functions. Whenever if you can take here the 2 samples and here also the 2 samples, my dear students. If you can take the here 1 and the here 2 means definitely both are not equal. the input is delayed with the 2 samples, means the entire system is also delayed with the 2 samples. Then only both are equal. Then we can call it as a time invariant. Okay. So without an ambiguity, default I am taking always a one sample is shifted. Following. And e power x of t, the step function, the x of t is delayed with one sample, and step 2, entire system is delayed with one sample. So both are the equal, time invariant system only. And coming to the linear time invariant system, linear time variant system, linearly. So time variant and the linear function, both I am combining the linear time invariant system. Any system which obeys linearity and time invariant property is called linear time invariant. See, if it is a y of t x square of t, so it is a linear time invariant, but it is not the linear system. It is not the linear system, my students. And similarly, the e power x of t, it is a time invariant, but it is not the linear system. Okay, whichever it is a linear and the time invariant system, then only we can call it as a linear time invariant system. If we can take these two examples, these two are time invariant, but it is not the linear. Okay, my dear students. Linear time variant systems. Any system which obeys the linearity and does not obey the time invariant property is called linear time invariant systems. Let the example is y1 of t, a1 x1 of t, y2 x2 of t. Y of t is equal to, both we can add, step 1 and step 2 is both are equal. This is a linearity and time invariant function. A into x of t, it is a is delayed with one sample, and in step 2, entire system is delayed, t minus 1 and a into t minus 1, both are equal. Then we can call it as ax of t and ax of t, linearity and the time invariant. Then we can call it as a linear time invariant system. Linear time invariant system. Similarly, y of t is equal to t into x of t is a linear time invariant system. We already seen some examples comparing which is a linear and which is a time invariant. Okay. And third one, y of t, ax of t plus b is a non-linear time invariant. Non-linear, because it is a non-linear and time invariant. A into x square of t, non-linear time invariant. Y of t e power 1 x of t, non-linear time invariant. Okay, see here the x square of t. It is a non-linear, but it is a time variant. E power x of t, non-linear, but it is a time variant. So non-linear time invariant, non-linear time invariant. Okay. Y of t is equal to x of t minus t naught, a linear time invariant. Okay. Coming to the next one, next property, or nothing but it is a classification of the systems, stable system and unstable system. Stable means for every bounded input, there is a bounded output. For every bounded input, there is a bounded output. Nothing but the stable system. If for any bounded input, the output is not bounded, then that system is unstable system. The integral minus infinite f of t dt is less than infinite. Bounded means finite value. Causal and non-causal. Causal means a system is said to be causal if output y of t naught depends only on the values of input x of t at t is less than the t naught, present inputs and the past inputs. Okay, it does not depends upon the future inputs. X of t minus 1 is a causal. X of t minus 2 plus x of t also. It depends upon the present and the past inputs, causal. Okay. 4 into x of t plus 1. It depends upon the future input. So it is not a causal system, it is a non-causal system. A system is said to be non-causal if the output depends on future values of input, that is, the future inputs and the outputs. Following my student. Now we go for some examples on stable system and the causal and non-causal system. Examples whether it is a causal and non-causal. Y of t is equal to k into x of t plus 1 minus x of t. T plus 1 is there. T plus 1. So definitely if it is a t plus 1, it is a non-causal. By seeing directly, we can say it is a feature input. And t plus 3, non-causal. T, x of t plus x of t plus 4, non-causal. Okay, my dear students. Here the t plus 3, x of t minus 3. T plus 3, it is not anything, it is not the signal, my dear students. Signal is x of t minus 3 only. It is a plus, non-causal. It is a minus only, causal system. Don't think that it is a t plus 3. It is not the signal. It is a coefficient only for the signal. Okay, causal system. X of 2t. X of 2t means if the t is equal to 0, here you have to know. I will explain here clearly. X of 2t, the time is multiplied. So y of t is equal to, what we are saying, it is a causal means present and the past. Present means x of t, past means x of t minus 1. Okay, present values. If I am taking the t is equal to 0, what is the t is equal to 0? It is a present value. The y of 0 is equal to x of 2 into 0. Okay. Okay, my dear students. But the t is equal to 1. T is equal to 1 means this is the present now. The 0 is there. X of 0 we got. Following. It is in the present only. The present. But if I am taking the t is equal to 1, what is the value we got here? The x of 2 into 1 means x of 2. Now I am in the 1, but it shows the output is in the 2, x of 2. So it is the feature. Okay, my dear student, it's a feature value. Understood? Whether it is shown, it is x of minus 1 or x of minus 2 or x of 1. Not it is a 2. Understood, my dear students? So it is a non-causal system. X of 2t is a non-causal. But the seventh example, see the y of t, x of t minus 1. X of t is a present. X of t minus 1 is a past. That is a causal system. Then coming to the eighth one, y of t is equal to x of t plus the integral 0 to dx of tau d tau. X of tau with the taking of the integral value, the upper limit is a t and the lower limit is a 0. Even if you are taking that, the value is that t is equal to 0, t is equal to 1 and so on, we'll get the present and the past inputs on. It is also the causal because it is a varies from the 0 to t. Understood, my dear students? So see here, y of t, x of t square. If I am taking the x of t square, either is a non-causal or the causal. T is equal to minus 1, x of 1. Minus 1, we are at the minus 1, but it shows the future value. T is equal to 0, okay, present. T is equal to 1, it is a present. And t is equal to 2, x value shows the future. So it depends upon the feature value, means y of t, x of t square is non-causal system. Non-causal system. See here the road that except t is equal to 0 and the t is equal to 1, the response of the any of the values is depends upon the future input. Following my students. So the causal system means it is depends upon the present and the past inputs. Then only we can call it as a causal system. Otherwise, it is a non-causal system. If it depends on the future input. If it depends on the future input, including with the present and the past inputs is there. If any one future input is there, that is a non-causal system. Okay, my dear students. Next to the impulse response. impulse response. Already we have discussed about this impulse response. The filter characteristics also is completed. Introduction and the distortionless transmission is completed. Amplitude distortion, causal system, and relation between rise time and the bandwidth is also completed. And now coming to the another problems here. We already explained these example. The impulse response of the continuous time system is given as. I also already told this is a example. Definitely you'll get it in the mid examination also. The given h of t 1 by RC, 1 by RC e power minus t by RC mu of t. Determine the frequency response and plot the magnitude and the phase. So h of omega is equal to h of t e power minus j omega t dt. Substitute the h of t 1 by RC e power minus t by RC mu of t. Change the mu of t as a 1. Change the limitations minus infinite to infinite is a 0 to infinite because of step function is 1 from 0 to infinite. Okay. Simplify the function. We'll get 1 by 1 plus j omega RC as h of omega. To draw the magnitude plot and the phase plot, we can rationalize with 1 minus j omega RC and 1 minus j omega RC. Numerator and denominator is multiplied. And again, you can simplify this function to get the magnitude is 1 by under root of 1 plus omega RC. Angle is minus tan inverse omega RC. Okay. When we can take the omega is equal to 0, omega is equal to 0 means second term is a 0, 1 by 1. The magnitude is 1 here. Omega is equal to infinite, 1 by infinite is a 0. You see the 0, slowly it is a decreases. And similarly, omega is equal to minus infinite, it is also slowly it is decreases. So magnitude plot is a symmetric. Magnitude plot is symmetric, my dear students. Symmetric. For positive values of t and the negative values of t, both are the same. Slowly it is a decreases here and slowly it is a decreases. Minus infinite is a 0, 0 is a 1, and plus infinite is a 0. Symmetric. Coming to the angle, phase angle minus tan inverse omega RC. At omega is equal to 0, tan inverse 0. Here the 0 is there. Omega is equal to minus infinite. Minus infinite means tan inverse of minus theta is a minus tan theta. Minus into minus is a plus. Tan infinite. Tan infinite means pi by 2. It's a positive value. So minus infinite, you get the pi by 2. And the graphical like this. This is a minus pi by 2. When you can take the infinite, omega is equal to infinite, what it gets? Minus tan inverse infinite. It's a minus pi by 2. Minus pi by 2. Okay. There's a line we have at omega is equal. Omega is equal to infinite and omega is equal to minus infinite and the 0. So varies from my plus infinite to the minus infinite, passes through the origin. Phase plot. Okay. It's a very important, definitely get in the mid exam, my dear students. Be thorough with this one. And coming to the next example. For the system shown, find the TT. What is the TT? Fourier transformation. Not the TT, it is a Fourier transformation and impulse response of the system. Fourier transformation, f of t is equal to e power minus at, the t is greater than, and 0 for elsewhere. Y of omega is equal to given 1 by a plus, not the a here, it is alpha plus j omega. For the impulse response means h of omega is equal to output by the input. Output by the input. What is output here? R of omega or y of omega. Y of omega by f of omega. F of omega is equal to, after the substituting the, not the substituting, to find the Fourier transformation of the f of t. F of omega is equal to, we know the e power minus at mu of t actually. They are not given the mu of t here, but given it is a t is greater than 0, greater than or equal to is also minus 1. Then only it is satisfied. Greater than or equal to. So 1 by a plus j omega. F of omega is equal to and y of omega is equal. What is the h of omega? Output by the input. Output is 1 by a plus alpha plus j omega. Input is 1 by a plus j omega. So a plus j omega and alpha plus j omega. Okay. You got the Fourier transformation of the given function and impulse response. Impulse response means h of t. We got the h of omega is equal. This is a Fourier transformation. Impulse response means h of t. Apply the inverse Fourier transformation of this function. A plus h of omega is equal to, we got a plus j omega by alpha plus j omega. Okay, my dear students. To get it is a h of t, you simply modify the numerator value as a plus alpha minus alpha plus j omega, whole divided by alpha plus j omega. So adding alpha and subtract the alpha is equal to, take a minus alpha by alpha plus j omega plus alpha plus j omega by alpha plus j omega 1. Okay, my dear students. A minus alpha is a constant. A minus alpha is a constant here. 1 by alpha plus j omega plus 1. Now you can apply the inverse Fourier transformation. H of omega becomes of h of t. A minus alpha is a constant. 1 by a plus j omega. You know, e power minus at mu of t. But instead of a, here alpha. E power minus alpha into t mu of t plus 1. What is the inverse Fourier transformation of 1? Delta of t. Fourier transformation is 2 pi into delta of omega. So we got to see the h of t is equal to alpha a minus alpha e power minus alpha into mu of t and delta of t. Got it, my dear students? Okay. Next example. The linear system impulse response is given. Okay, my dear students. So in the time domain function, so h of t is equal to e power minus t plus e power minus 3t mu of t. Find the excitation to produce an output of t e power minus 2t mu of t. T e power minus 2t mu of t means input function is given. Excitation means it is given of the input function. Okay. So h of t is given e power minus 2t mu of t and r of t is given t into e power minus t mu of t. Alright. The h of omega is equal to r of omega by the f of omega. F of omega is equal to r of omega by h of omega. What is the h of omega? The value is h of omega is equal to e power minus t mu of t and e power minus 3t mu of t. You can find out. And the next one is a t into e power minus 2t mu of t. We know e power minus at mu of t, the Fourier transformation, we know the 1 by a plus j omega. When it is multiplied with the t into e power minus at mu of t, it's a square. A ramp function is multiplied means a plus j omega whole square. Okay, my dear students. Now, given the t into e power minus mu t, for the h of t, h of omega is equal to, what is the first function? E power minus t mu of t means 1 by 2 plus j omega plus 1 by e power minus 3t mu t means 3 plus j omega. H of omega we got. Next one is r of omega. R of omega is equal to, the given is a 2 into e power minus t mu of t. What is a 2 into e power minus t mu of t? 2 plus j omega. It is multiplied with the t square term. To find out the f of omega, to find the excitation, h of omega is equal to, actually the output is r of omega by f of omega, and the f of omega is equal to r of omega by the h of omega. Okay, my dear students. Now we can write the r of omega as 1 by 2 plus j omega whole square whole divided by 1 by 2 plus j omega plus 1 by 3 plus j omega. Simplify this. How we get the simplification? 3 plus j omega plus 2 plus j omega means a 5 plus 2 j omega, and the denominator is there. It get cancel off 1 power here, 1 power, and simplify. The next one, see already the simplification is done here. H of omega is 1 by 2 plus j omega, h of plus 1 by 3 plus j omega. Now taking off LCM here, 5 plus j omega is in the numerator and denominator is a 2 product. On square it get cancelled. Now 1 by 2 plus j omega is in the denominator and into the 3 plus j omega is goes in the numerator and 5 plus 2 j omega is in the denominator. So now it is in the 3 plus j omega by the 2 plus j omega into 5 plus 2 j omega by using the partial differentiation. Okay. Take the a by 2 plus j omega and the b by 5 plus 2 j omega. So to find the a and the b values, r of omega is equal to 1 by 2 omega minus 1 by 5 plus 2 j omega is equal to, again you can find the r of t is equal to e power minus 2t mu of t minus 1 by 2 into e power minus 5 by 2 into mu of t. Is a given function, the trigger function. Okay. What they're asking here, see, the linear function, the linear system impulse response is e power minus 2t plus e power minus 2t by the mu of t. The f of omega is the input if I am taking. H of omega to get the output is r of omega. Okay, r of omega is output by the input value, the f of omega. It is not there, it is a f of omega. We are finding out the f of omega, taking off h of omega. So here the f of omega, my students, not the f of omega, f of t. Here it is not the r of omega. There is something wrong. It is f of omega. Now it is a f of t, not the r of t. F of t. It is also f of omega because already given is r and f, r and y. F of t is equal to. Okay, my dear students, f of t is equal to produce the input function of f of omega is equal to find the excitation to produce the an output of this output. R of omega is output. Find the excitation means you have to find out the f of t, my dear students. It is r of omega, okay, and this also h of omega is okay, but f of omega is equal to, we are simplifying. This is a f of omega, not the r of omega, my dear students. Please modify. When I've sent this as a PDF for your material as a 4th unit for sum of the and 3rd unit for the sum of. So change this. When you are listening, then only can there is any mistakes is there in the material, you have to modify that one. F of omega, and here is also f of omega, and this is a f of t. The excitation produced due to the output of r of omega, f of t is equal to 1 by 2 plus j omega is e power minus 2t mu of t minus, and here there is a 1 by 2. The 1 by 2 is there. Because why it is a 1 by 2? Actually, it is a plus j omega only. How to take? See here, 1 by 5 plus 2 j omega. There is no any directly inverse Fourier transformation. Take the 2 as a common here. Because a 1 by a plus j omega only we know as a Fourier transformation is for e power minus at mu of t. We don't know that the 5 plus 2j omega. It is a 1 only, the j omega. So keep that, it is a 1. Simplify that is equal to, take as a 2 common in this, 2 as a common, 5 by 2 plus j omega. Now the 1 by 2 is there, is a multiplication factor. Now a is e power minus 5 by 2 into t mu of t. Understood, my dear students? Don't confuse and don't write the e power minus 5t mu of t. Here the 2 is there. For j omega is multiplied the 2 because the j omega always you can see it is a 1 only. So 2 1 by 2 is in the coefficient and e power minus a is a 5 by 2 into t mu of t. Okay, my dear students. Now coming to the next one, the differential equations, the examples. Differential equations. So the differential equation, to obtain the frequency response and the impulse response. To obtain frequency response and the impulse response, a differential equation. Differential equation. See the sum of k is equal to 0 to n a suffix k d power k d t power k y of t is equal to sum of n is equal to 0 to m b suffix k d power k dt power k x of t. Okay, my dear students. Differentiation property of Fourier transformation. In the Fourier transformation, the differentiation property is a d by dt of x of t is a j omega into x of omega. J omega into x of omega. So now you can apply that as a differentiation with k power. Sum of k is equal to 0 to n a suffix k j power j omega whole power k y of omega. And here the b suffix k j power j omega whole power k and x of j omega. Output by the input we call it as a system transfer function or the system function h of omega is equal to y of omega by the x of omega. That is equal to sum of k equal to 0 to m b suffix k j omega whole power k and sum of k is equal to 0 to n a suffix k j omega whole power k. So both are cancelled, b suffix k and a suffix k only will get. Okay. Don't use that directly. You can apply the differentiation. Use the property. Whatever we know the property is a d by dt of x of t. The Fourier transformation is j omega into x of omega. If nth derivative x of t, the Fourier transformation is j omega whole power n x of omega. Okay, my dear students. Here, whatever the n is there, either it is a square, j omega square, 3 j omega cube, 4 j omega 4. Use this function in the differential equation directly to find the Fourier transformation. Okay, you will get a little bit confusion by using the differentiation equation. If you remember that one. It is useful in the further for the EC students. There is another subject is there. Application of the signal system, nothing but the digital signal processing. In that, it is useful for the differential equation. Okay. Otherwise, forget about this one and you remember the nth derivative of x of t signal. The Fourier transformation is j omega whole power n x of omega. Okay, my dear students. Tomorrow we can see the some more examples in the differential equations. Some more examples in the differential equations of the system. Understood? Any doubts, my dear students? Any doubts? Thank you.